And I wrote the tan inverse of V2 over V1. So that's true. That's one way to find the direction angle. Another way is you could use the cosine inverse of the horizontal component, which would be V1, and you could take that and put it over the magnitude. It all depends on what you're given in the problem. Just understand, for your direction angle though, you always want your angle to be the angle that, like if I had it here, the angle that is formed from rotating from the standard position. And standard position is if I would go positive out on the x-axis. So you may write this on your formula sheet as well, but sometimes you're going to need to add 180 because, as I said earlier, the inverse functions, in order to be a function, they can only output one angle. But there are going to be two angles in a full rotation that have the same tangent value and the same cosine value. And so just be aware of that. Depending on the problem, you might have to add 180. Okay, we just did an example like this, right? So we're going to find the magnitude and direction of the angle -3, or the vector -3, 1. I don't think this is an issue for most of us at this point. I like to sketch my vector. So this just means that's the terminal point there. So starts at 0, 0, ends at -3, 1. The magnitude of the vector is the square root, it's using Pythagorean theorem, of -3 squared plus 1 squared, so the square root of 10. I know I'm going quickly, but that's pretty, you showed me, most of you showed me that you know how to do that. All right, now, just in case, because some of you might not have gotten the same angle and you were wondering where you went wrong, if I wanted to find theta, which is how far this vector has rotated from standard position, do we all agree that it's between 90 and 180? Yeah. Okay. So we're going to make sure when I use inverse functions that your calculator is in degree mode. So if you got it right in the opener, you don't have to worry about that anymore. My calculator is not in degree mode, so I'm going to switch it to degree mode. And now, do you see how I have both the magnitude and the components? So you can use either formula you want. In this case, cosine inverse I think gives you the right one without having to add 180. Tan inverse I don't think does, but let's just see. What's the tan inverse of 1 over -3? Let's round to -18.5, okay? And this is a case then where I'm just going to go ahead and add 180 to that, and 161.6, oh well, it's 0.5 or so. Okay, if the vector was down here, I would be in the right spot. Just so we're clear, in this one, like I said, cosine inverse would work. What is it? -3 divided by square root of 10. So do you see how cosine, you don't have to add 180? That's not always the case, just kind of depends on where the position is. But okay, cool. Now, we went this way, let's go backwards. What if I give you the angle and then the magnitude? That 35 is not an angle, it's the magnitude of the vector. And I ask you to find the component form. So we're going to add this in here, okay? if you are finding the component form, this was if I had two ordered pairs. The other way, this is again if you have the, using this picture here, if you have the magnitude and the angle, you're going to just use some trig. The first component, you take the magnitude and you multiply by the cosine of the angle. And the second, you take the magnitude and you multiply by the sine of the angle. And this just has to go, if you go back and think of SOHCAHTOA, you're basically finding the, using the SOHCAHTOA ratio to find the x coordinate and the y coordinate. Right, so you're going to want to add that component form formula also to your formula sheet. Okay. So, if I was finding the component form of this, then I would just take 35 times the cosine of 60 degrees. And then for the horizontal or the vertical, 35 times the sine of 60. All right, let's do that. I get 17.5. And 30.3. Okay. Any questions on that? So this is obviously not to scale, but hopefully you can see that this goes over, and it definitely 30 is bigger than 17.5, and it goes up more than it's going to the right. So that would describe that vector. Okay, then my favorite, application problems. It'll become your favorite too. Yeah. All right, so first of all, a word about this term, a bearing. Who knows what a bearing is in navigation? It is from, it's from, yeah, on a compass, where is the starting point? North. This is why this causes a little bit of an issue with us, because where are we starting our angle? We're starting at east, okay? So bearing, just so you're understanding, is clockwise, is an angle clockwise from the north. Okay, so now it might not always give you a positive angle, but that's okay for our purposes. To find theta from that, what you're going to do is take 90 degrees minus the bearing. Because to use our formulas, we need to have an angle from the x-axis. And as I said earlier, it might not always give you a positive angle, but for our purposes, it will give you the right spot, and that's what we care about. Okay, because if we're going to put the sine or the cosine in there, it doesn't matter, that they will be calculated correctly. So I have a jet flying on a bearing of 65 degrees at 500 miles per hour. Find the component form of the jet. Okay, all that means is we're going to break down the jet, its directions, like essentially how much is pulling it to the right, east, how much is pulling it north. So first of all, I'm going to find theta. If it's flying at a bearing of 65 degrees, I'm going to take 90 minus 65. What is 90 minus 65? Okay, the magnitude of the vector is the speed of the jet, so that is 500 miles per hour. All right, so if I was just kind of like, this was my it's my XY axis, it's also my compass. I go 65 degrees. There's the jet, if you will. All right, we're trying to figure out what's its horizontal component, essentially what's its speed going east and what's its speed going north. So we use our formulas. Whoa. Crazy. He doesn't want to. I don't know. I didn't even know I was supposed to range it. All right, 500 cosine 25. Would you guys do that for me? Let's round to the nearest. Let's do 3 decimals. 1,000. 1.5. Okay. And then what's 500 sine 25? 0.309? Okay. So essentially, all that kind of means is, and I know it doesn't really work like this, but if you were figuring out the speed of the plane horizontally is this, if you were breaking it up, and the speed going vertically is this, which makes sense because this is being pushed out more to the right than it is up. Okay.
Whatever that direction is, northeast.
Huh?
If the plane were only able to travel east then north,
Yes.
okay, that'd be the miles.
I thought you were asking this question. So here's what normally, if you're flying, what's a factor? Wind. So if we really wanted to get into it, I have one that's kind of similar with forces, but if we really wanted to get into it, then that wind could be a vector, and we'd have to add the wind vector to the plane's vector and figure out what direction the plane is actually going. Or we could figure out what the plane what its bearings should be to get it on the right course. Okay, all of those things are vectors. Vectors are very much like a navigation kind of thing. So let's take a look at this one. So basically on this kind of problem, you are having 2 different forces. And so we talked about this earlier on. If I'm pulling something one direction and Paul was pulling the other direction, the object would not go, well, unless my force, okay, but probably the object's going to go somewhere in between, okay? So what happens is the resultant is the sum of the 2 vectors. And we learned before, can't we add vectors together? However, what kind of form do they have to be in to add them together? They have to be in component form, okay? So what we're going to do in this problem is we're going to put these vectors in component form, and then we're going to add them together to figure out the result of the object. All right, so a force of 75 pounds, that's going to be the magnitude, acts on an object at an angle of 30 degrees. All right, so would you draw a vector that you think would be 75 pounds? How do you draw that? I don't know. But the angle of 30 you can do. So here's a 30-degree angle. And in a second, we're going to find the components of that. A second force of 100 pounds. So the key here is this vector, should it be longer or shorter than the vector I drew earlier? Longer, because it's got a stronger force. This is at an angle of -15. So I'm going to drop down to negative 15, and I'm going to draw a vector that is longer. That might be too long, but. And we're going to make sure we put that negative 15 there. What I want to know is, where is the resultant force going? So we're going to find the new magnitude and angle when we're all said and done. Okay. Are we ready? We have our drawing. How do we find the magnitude of this? 75 times cosine of 30. And this is 75 times sine of 30. I should have left more room. This is 100 times cosine of negative 15 and 100 times sine of negative 15. So, to get the resultant, instead of like wasting time typing all those things in, I'm going to have to add these two, right, together. So would we all be in agreement that the result vector is going to be 75 cosine of 30 plus 100 cosine of negative 15? Right? And the second component is going to be 75 sine of 30 plus 100 sine of negative 15. Please do not, somebody's going to do it on the test, just add 75 and 100 together and add 30 and negative 15 together to get the new angle. It doesn't work like that. All right.
I'll do it all. I'm gonna do it.
If you did, the cosine of 345, is like negative 15, would you still get the same answer?
Yes, as long as it's in the same spot. All right, so I'm going to do my horizontal one in a minute. I'm going to round to the nearest thousand. I get 161.544. Just confirm you get the same thing as me, please. Check my math. And I got 11.618. Is that what you got? Not yet. Not yet. So this is the result. This is the result of the actual object's direction. Remember how I asked you to find the direction and magnitude? Do you know how to find the direction and magnitude of a vector? All right, let's just leave this stuff in our calc and do it. So I take 161.544 squared plus 11.618 squared.
164, not 161.
I take the square root of that answer and I get 164.9536. What? What did I type in wrong? Well, crapola. Yeah. I was just ignoring you all. You were warning me. 161.961? Okay. That's the magnitude. What would be the units? Pounds. And theta, I'm going to do tan inverse of 11.618 over 161.544. And I get 4 degrees. Okay, so hopefully that makes sense. Because even though this force was smaller than this, the angle was less than 30, so the result is it's still gonna be going up in this direction. All right.